Hello, welcome to IMS GATE Academy. Myself, Sandeep Adari. I have done my BTech from JNU Hyderabad and MTech from NITK Suratkal. One second, students. Okay, welcome to IMS GATE Academy. Myself, Sandeep Adari with GATE Air Rank 192 with 10 plus years of teaching experience. Now, welcome to IMS GATE Academy on the occasion of Engineers Day. We are celebrating the Engineers Day with a previous year GATE YouTube session on civil engineering. Now, my dear students, we are going to cover important topics related to RCC. So, as part of this, the first and the foremost question and the interesting question in one of the GATE exam is a singly reinforced concrete beam of width, rectangular concrete beam of width 300 mm and effective depth 400 mm is to be designed using a M25 concrete. And one more important thing is effective depth here is how much given, my dear students? 400 mm. Is to be designed using M25 concrete, and also, my dear students, the grade of steel here is Fe 500. For a beam to be under reinforced, what is the maximum number of 16 mm dia bars? This is a famous question, sir. My dear students, I just want to explain you some important concept here. Sir, see, my dear student, for any beam to be under reinforced, first of all, amount of steel provided is less than the amount of steel required to balance the section. When do you say that a beam is under reinforced is amount of steel provided is less than the amount of steel required to balance the section. That section is said to be a under reinforced. And one more thing, important point I would like to tell you is in under reinforced section, my dear students, the failure is in steel. As steel is a ductile material, my dear students, I want to tell you very important thing is the sign of failure will be evident, or you can clearly see the sign of failure. Practically, all the sections are designed as under reinforced. This is the important thing I would like to tell you. Now, my dear students, for this problem to be done, I will explain you in a very simpler way, Amma. See, first of all, we will calculate, we assume the section to be, first of all, we assume the section as, my dear students, first of all, we assume the section as under reinforced. We assume the section as what, my dear students? We assume the section as under reinforced. This is the first and foremost thing, because we assume the section as under reinforced because he has clearly told that the section is under reinforced. Now, we have to find out the AST limiting. We have to find out the limiting area of steel. To find out the limiting area of steel, we can assume the section as balanced section. We assume the section as what, my dear students? As balanced section. Now, when I assume the section as balanced section, we have two parts. One is nothing but 0.36 FCK B into XU is equal to 0.87 Fy AST. Remember, my dear students, we have compression force is equal to 0.36 FCK BXU is equal to 0.87 Fy AST. As it is a balanced section, we can assume that XU is equal to XU max and AST can be written as AST limiting. This is the one of the important point I would like to add here. Whenever a section is balanced, we can assume that XU is equal to XU max, my dear students. And we can also say that AST can be assumed as AST limiting. Based on these conditions, we can calculate the limiting area of steel. Now, my dear students, when I talk here, we have the important thing. The grade of concrete given is M25 and the grade of steel here is Fe 500. My dear students, the grade of concrete is M25 and grade of steel is Fe 500. Using these conditions, my dear students, I will calculate the AST. So 0.36 FCK is 25, my dear students, and width of the section is how much, my dear students? Width of the section is 300. Width of the 300 is 300. XU max, and remember, my dear students, XU max is equal to 0.87 and grade of steel is how much, my dear students? Grade of steel is Fe 500 and AST limiting. We consider this as AST limiting. Now, my dear students, when I explain you here, it is a Fe 500 grade of steel. Regarding Fe 500 grade of steel, my dear students, XU max by D value is given as 0.46 value, or you can write XU max is equal to 0.46 D. And to add for any problem, my dear students, if I consider Fe 250 grade, my dear students, when I consider Fe 250 grade, XU max by D is 0.53. If you consider Fe 415, it is the value is Fe 415, the value is 0.48 D. So here, based on the different grades of steel, the XU max by D value changes. But here the Fi value is Fe 500. Hence, we can take the value as 0.460. So, if I substitute this value, my dear students, if I substitute 0.3625 into 300, what is the value of XU max, my dear students, here? It is nothing but 0.460. It is nothing but what, my dear students? It is nothing but 0.46 D. D is nothing but, again, what is the value given in D? D is nothing but 400, sir. So, D is nothing but 400. If I solve this, AST limiting. Now, when I solve what is the limiting area of steel, limiting area of steel can be taken as AST limiting can be taken as, after calculation, and substitute the value of D as 400, 0.36 into FCK is how much, my dear students? FCK is nothing but, here FCK is how much? FCK is nothing but 25. Width of the section is 300 and we have a value how much, my dear students? It is 0.46 into 400 divided by 0.87 upon 500. So here you can write the limiting area of steel is how much? The limiting area of steel is nothing but 1142. You can say that limiting area of steel is around 1142 mm square. See the concept, the beauty of this concept you have to understand. For a beam to be under reinforced, here what is the condition? The condition is as simple as that. AST should be less than or equal to AST limiting. For a beam to be under reinforced, AST should be less than or equal to AST limiting. Now, he has asked in the problem, calculate the maximum number of 16 mm dia bars. He has asked to calculate the maximum number of 16 mm bars. Here, can I take n into pi by 4 into 16 mm square? Because the number of bars is, dia bar is 16. 16 square is equal to AST limiting, that is 1142 mm square. Now, my dear students, when I calculate n value, 1142 divided by pi by 4 into 16 square, that will be equal to around 5.68. The number of bars should be equal to how much, my dear students? It will be equal to 5.68. Is it clear, sir? So, its value is equal to 5.68, or you can say approximately 5.7 bars. Now, my dear students, when I talk about this is the important thing. Most of the people in the GATE 2018, they have written the answer as 6. which is absolutely wrong. See, whenever you have provided more number of bars than the limiting area of steel, sir, here limiting area of steel is 5.7. Okay, but 6 is absolutely wrong. Why I am telling is, you are providing the area of steel more than the limiting area. So then the section will become over reinforced. Then the section will become over reinforced. So that is a false answer. But for a beam to be under reinforced, any value less than 5.7 is correct. So it can be 1 can be correct, 2 can be correct, 3 can be correct, or 4 bar can be correct, or 5 bar. The beauty of this question is, out of these, he has asked what is the maximum number of, what is the maximum number of bars. So the maximum number of bars is, here is 5. So the option here is 5. You can write here, the option is 5 number of bars. In the option we have C option. So this is the one I would like to tell you. So I just want to summarize in this question, my dear students. A singly reinforced concrete beam of width 300 mm and effective depth 400 mm is designed using M25 concrete and Fe 500 grade of steel. For a beam to be under reinforced, calculate the maximum number of 16 mm dia bars. This is the question they have asked you. Now, this question, whenever these kind of questions are given, I want to tell you some important points where any problem can be solved, my dear students. So first condition is calculate the limiting area of steel. Now how do you calculate limiting area of steel is assume the section as balanced. Actually there are 3 types of sections, my dear students. One is balanced section, over reinforced section, and under reinforced section. Practically all the sections are under reinforced because under reinforced sections clearly show a sign of failure. Over reinforced sections are completely avoided because the failure will be sudden. Then a beautiful question can be asked by your students. Why do you assume balanced section? To understand the depth of the neutral axis, to calculate the limiting area of steel, we assume the section to be balanced. So the first point you can assume is assume the balanced section and calculate the limiting area of steel. Apart from that, once you have calculated AST, my dear students, you can compare the conditions that XU should be less than XU max and also AST should be less than AST limiting. These are the 2 points where they can ask you, based on these 2 points, any problem in under reinforced can be solved. I hope you are clear with this problem. Next, there was another beautiful question in shear, my dear students. My dear students, RCC is a subject in civil engineering where it carries 4 marks in GATE exam. My dear students, in RCC, we have to study very, very important topics like limit state method, and we also have to study shear, and we also have to study pre-stressed concrete. These are the important things which you have to study, my dear students. Now, why do you want to study about shear? See, my dear students, when I talk about RCC, when I talk about shear reinforcement, what is the importance of shear reinforcement, my dear students? See, my dear students, due to shear, there can be 2 reasons of failures. One is diagonal compression failure and other one can be diagonal tension failure. There are 2 types of failures. One is diagonal tension failure and another one is diagonal compression failure. Diagonal tension failure will be taken care by means of stirrups, whereas diagonal compression failure, my dear students, they take care using Taussig max. Taussig max is a condition where they will identify whether the diagonal compression is done or not. For any section, we don't assume or we don't allow the diagonal compression failure. For any section, my dear students, we don't assume any diagonal compression failure. We check for diagonal compression failure, my dear students. If suppose tau is greater than Taussig max, we have to redesign the structure. This is the basics of shear. When a section is subjected to pure shear, there can be 2 reasons. Now, when I talk tau v greater than tau c max, what is the failure you can have is diagonal compression failure. The failure you can have is diagonal compression. Now, my dear students, any doubts? राकेश वर्मा, गुड मॉर्निंग सर. हिंदी में बात राकेश वर्मा, आपका डाउट है तो मैं हिंदी में बात किया. ओके. Now see sir, here the factored shear force is how much? अगर कोई sir, if anyone is having any doubts, you can always ask me amma. Sir, here the factored shear force is given as 200 kilonewtons at critical section. Width of the section is 250 mm. Effective depth is 350 mm. Tau c is 0.62. Tau c max is 2.8 Newton per mm square. Vijay Agarwal sir, thank you. If two-legged 10 mm stirrups, if you have two-legged 10 mm stirrups, we have Fe 250 grade of steel, and what is the required spacing? So the important point for any GATE student, if you are preparing for GATE, my dear students, the foremost important thing is you have to read the question twice, because reading the question twice and putting the formulas is very important when you are solving the problem. So please keep this in mind, my dear students, whenever you are solving a GATE question. It is my sincere advice to all of you. Now, my dear students, the given question problem, here the shear force is given as, here if you see the shear force is given as 200 kilonewton. Next, what is the width of the section? Width of the section is 250 mm. Width of the section is 250 mm. And effective depth D is equal to 350 mm. And tau c max, my dear students, tau c max is a function of concrete only. This was a previous GATE question also. What is a tau c max? Tau c max is function of grade of concrete only. Now, my dear students, tau c max value is given as 2.5 Newton per mm square, and tau c is equal to 0.62 Newton per mm square. And dia of steel is 10 mm, and we have, it is two-legged. It is a two-legged is given. And what is the spacing? This is the question they have asked, my dear students. Whenever these kind of questions are asked, first of all, the first and the foremost step we have to solve, my dear students, is nominal shear stress. First of all, what we have to do? We have to calculate the nominal shear stress. How do you calculate nominal shear stress, my dear students? Nominal shear stress is calculated, tau v is equal to Vu upon Bd. Tau v is equal to Vu upon Bd. And what is the shear stress given here, my dear students? What is the shear force? Shear force is nothing but 200 kilonewton. If we convert into Newton, it is 200 into 10 power 3. Now, my dear students, if you like this session, please share to your friends and enjoy these sessions on YouTube. And these sessions are provided for each and every session, each and every subject, important subjects in civil engineering. Not only civil engineering, we are conducting the YouTube sessions on all the branches. So it is all the students utilize this opportunity. Please like and share the session. And here we have the width of the section is 250 mm and depth here given is 350. Now, when I calculate what is the nominal shear stress, here we have calculated is, if you have calculated nominal shear stress, it is 2.286 Newton per mm square. Now, my dear students, here when I calculate tau v is greater than tau c. Whenever tau v is greater than tau c, shear reinforcement is mandatory. Whenever tau v is greater than tau c, shear reinforcement is mandatory. Shear reinforcement is mandatory. And remember, my dear students, when tau v is not greater than tau c max, if tau v is greater than tau c max, then we have to redesign. But here tau c max is 2.5 and tau v is 2.286. So tau v is not greater than tau c max, hence no redesign. Now, what is the condition for shear reinforcement mandatory is, you can write that design shear force will be calculated using the formula tau v minus tau c, b into d, that is equal to what is the value of tau v? 2.286 minus tau c is how much, sir? 0.62. Width of the section is 250. Effective depth of the section is 350. So when you calculate this design shear force, you will get a value of around, now my dear students, you might get a value of 145.7 into 10 power 3 Newton. If you convert this, it will be 145.7 kilo Newton. This is the answer you might be getting for design shear force. We have design shear force can be also calculated using the formula 0.87 Fy ASV into D upon SV. Here, my dear students, you know what is the grade of steel, Amma? The grade of steel is nothing but 250. And how many legged or two-legged stirrups are used? And the dia of stirrup is pi by 4 into 10 square. Okay. And we have what is the effective width, my dear students? Effective depth is given as how much, my dear students? Effective depth is given as 350 upon SV. Now, my dear students, we have equate this equation and this equation. That means 145.7 into 10 power 3 is equal to 0.87 into 250 into 2 into pi by 4 into 10 square into 350 upon SV. So from this, my dear students, SV can be calculated as a value of around 82 mm. And remember, we have a check, SV should not be greater than D. Yes, it is not greater than D, and SV should not be greater than 300 mm. So SV can be taken as 82 mm. If they asked you the answer in 8.2 centimeters, the answer is 8.2. So, my dear students, whenever you are preparing for RCC, in RCC, my dear students, what do you mean by RCC? Means reinforced cement concrete. What do you mean by reinforced? Means make it stronger. So, my dear students, in RCC, we have one method called limit state method. Why limit state method is most appreciated? Because limit state method is a method of designing a structure based on statistical concept of safety and probability of failure, or it is the ultimate stage at which the structure is unfit for use. Now, in many of your interview questions in RCC, why do they use steel and concrete? This is the common question they can ask you, my dear students. Why do they use steel and concrete? This is the common question they can ask you. Why do they use steel and concrete? Is remember, these are some of the interview questions which I've asked in some of the IITs also. Why do they use steel and concrete? Is the coefficient of thermal expansion for steel is almost same when compared to the coefficient of thermal expansion of concrete. That is the reason in RCC we are using steel and concrete. Apart from this, if you see the factor of safety of concrete, the factor of safety of concrete in LSM method is 1.5. If you consider the factor of safety for concrete, it is 1.5. And if I consider for steel, it is 1.15. The factor of safety for steel is 1.15. Now, my dear students, why the factor of safety for concrete is more? Why the factor of safety for concrete is more compared to the factor of safety of steel? Can anyone answer the reason? The reason is simple. In one of the interviews, they have asked it. The reason is quality control. Why? Because, sir, steel is manufactured in industry. As steel is manufactured in the industry, you can know that their specifications are exact. But whenever concrete is manufactured, concrete is made in a laboratory and you are not sure. That is the reason, my dear students, when you calculate the compressive strength of concrete, you take the average of 3 cubes. If you are confident, then you will take the average of 1 cube only. But why you are taking the average of 3 cubes? This is the reason. So why do they use steel and concrete in RCC? The reason is the coefficient of thermal expansion of steel and concrete are almost same, and the factor of safety for concrete is 1.5 and for steel it is 1.15. The reason is quality control. Now in the previous question, my dear students, we have discussed about shear. Now the main important term, my dear students, in RCC, if we consider load transfer mechanism, what exactly is load transfer mechanism, my dear student? Whatever the load which is falling on the slab will be transferred to the beam and then to the column and then to the footing. For every structural element, there is a design criteria. If we consider footing, the design criteria is shear. Why it is shear is based on the shear, that is one-way shear or two-way shear, the depth of the foundation is highlighted. In columns, the design criteria is buckling. If it is a short column, crushing. If you consider the design criteria for beam, it is bending. If you consider the design criteria for slab, it is deflection. When I talk about shear, my dear students, I just want to tell you, why do you want to design for shear? Because, my dear students, whenever there is a column or anything, we always design shear to overcome the crack sum. Due to shear, my dear students, if any section is subjected to pure shear, there can be a chances of diagonal compression or diagonal tension failure. So diagonal tension failure can be taken care by stirrups and diagonal compression failure will be taken by Taussig max. Why I am telling this so many times, my dear students, there was a 2-time IES question as well as GATE question that diagonal compression failure is taken care by Taussig max. My dear students, diagonal compression failure is a sudden failure and which is not at all acceptable in GATE. So that is the reason we are not allowing the diagonal compression. And diagonal compression failure will be taken care by stirrups. And you can have reinforcement in stirrups or inclined stirrups, or you can also have in bent up bars. So these are the common important things related to shear. I hope you are enjoying the sessions from IMS GATE Academy. My dear students, utilize this opportunity. Please like, share and share to your friends. It would be a great help for them because the concepts related to the GATE or previous GATE questions, it is not just solving the previous GATE questions. The underlying concept here is very well explained. So please share to your friends, my dear students. Now, here the question here is a reinforced concrete slab with effective width how much, my dear students? A reinforced concrete slab is there here and we are having an effective width. What is the effective width here, my dear students? Whenever we are talking about the here, we are a reinforced concrete slab with an effective width 80 mm with an effective width effective depth of 80 mm is simply supported at two opposite ends and the thickness of the wall is 230 mm. The center to center distance between the wall is 3.3 meter, my dear students. As per IS 456, what is the effective span of the slab? This is the question they have asked, my dear students. Whenever these kind of questions are asked, first of all, you should understand what is effective span. Now, whenever I am talking about effective span, my dear students, effective span for simply supported beam, there is a condition from IS 456. What are the two conditions we have from IS 456 is, one is the center to center distance between the supports. Effective span will be calculated based on center to center distance between the supports and next one we have is what, my dear students? We have clear span plus D. We have next one is clear span plus D. Out of these two, my dear students, whichever is smaller value will be considered as effective span. Whichever is smaller will be considered as effective span. Now, my dear students, what is the given data? The effective depth is given as how much? The effective depth is given as D is equal to 80 mm. And we have Next, thickness of masonry wall. When I talk about the thickness of the masonry wall is given as 230 mm. So when I talk, this is 230 mm. If I convert into meter, effective depth will be equal to 0.8 meter. Sorry, 0.08 meter. Effective depth will be equal to how much? 0.08 meter. And effective thickness will be equal to 0.23 meter. So this is the given data, and they have given center to center distance as how much, my dear students? Center to center distance is given as 3.3 meter. Now this is the one of the option, means A is given as 3.3. Now if we consider simply supported beam here, my dear students, if I consider simply supported beam here, the center to center distance between the center to center distance is given as how much? 3.3 meter. Now what is the thickness of the wall? It is given as how much? 3.3 meter. Now the thickness of the wall here is given as, this thickness is given as 230 mm. Or so how do you calculate the clear span here? Clear span is simple. Center to center distance between the clear span is equal to, you can see the diagram, my dear students. Here clear span can be calculated as, this part is nothing but clear span. This part, whichever I am writing in shaded, this is nothing but the clear span. So clear span can be written as 3.3 meter minus thickness of the wall is how much? 0.23. How you can understand, my dear student? Here half thickness you have to remove, and here you have to remove half thickness. So half thickness plus half thickness, you have to remove the full thickness. So clear span is equal to 3.07 meter. Now my dear students, when I calculate the effective span here, what will be the effective span here? Effective span will be equal to 3.07 meter. That is clear span plus effective depth is 0.08 meter. So the total value you have is 3.15 meter. Now my dear students, we have center to center distance is how much, sir? Center to center distance is 3.3 meter and effective span is 3.15 meter. Okay, 3.15 meter and 3.15, 3. Out of these, whichever is smaller will be your answer. So the smaller is nothing but 3.15 meter. The smaller is nothing but 3.15 meter. Any queries, you are always feel free to and message me in the chat box, my dear student. Students, it is your responsibility, or you can utilize this opportunity to share to your friends and use this YouTube series session for GATE. Now, my dear students, we have another question. The question here is simple, amma. The question is the frequency distribution of, 20 concrete cube specimens are given in the table. That is 23 strength of 4 cubes, 28 of 5, and we have 22.5 of 5, and 31 of 5 and 24. If mu is the mean strength here and sigma is the standard deviation, what is the number of specimens with compressive strength less than mu minus 3 sigma? So here, my dear students, I want to explain you one important topic. What is characteristic strength? Characteristic strength is defined as the strength at which 95% of the test results are expected to pass. It is the characteristic strength of concrete is the strength at which 95% of the test results are expected to pass, or only 5% of the test results are expected to fail. So this is what exactly is characteristic strength. Now when I talk about the characteristic strength here, my dear student, he has given in the problem, mu is taken as what, amma? Mu is calculated as mean strength. So what exactly do we mean by mu is? It is nothing but mean strength. So when I talk about the mean strength, it is nothing but the average. So how do you calculate the average? we have how many specimens of 23? 23 strength, we have 4 specimens of concrete. Next, similarly, we have 28 strength of 2 specimens. And similarly, we have 22 point of how many specimens we have is 5 specimens. And similarly, we have 31 strength of 5 specimens. And similarly, we have, sir, these are all the given data, 30 and 29 of 4 specimens. So how many concrete cubes are there here, my dear students? Concrete cubes are 4 plus 2 plus 5 plus 5 plus 4. It is nothing but 20. No need to count 20 also. Why? Because in the question itself, they have given it is 20 concrete cube specimens. So if you calculate this, mu will be equal to 26.575 MPa or Newton mm square. Now, my dear students, when I talk about the graph, if we calculate this as the target mean strength and above 5%, we call this as characteristic strength, means 95% probability curve. The distance from here to here, we call it as standard deviation. Sir, these are nothing but statistics. Now, how do you calculate the standard deviation? Standard deviation is given by the formula sigma square root of sigma. If I take individual strength as Fi, if I take the strength of the individual strength is Fi minus one second, my dear student, F minus mu whole square upon n minus 1. So this is the formula for standard deviation. This is the formula for what's a standard deviation. So here when I talk about the standard deviation, we have the numbers here. The numbers are 23 and the average is 26.575 whole square. And how many cubes are there of this 23 strength? 4 cubes are there. They are 4 cubes into 4 plus we have 2 cubes of 28 strength minus average is 26.575 whole square. And similarly, we have 5 cubes of 22.5 and the average is 26.575 whole square. And we also have 5 cubes of 31 and similarly we have 4 cubes of 29. We have 4 cubes of 29. And if you calculate this, average is same 26.575 whole square. If we do the square root of all these terms and if we have the term and number of cubes is how much, sir? Number of cubes is 20 minus 1. If we calculate here, standard deviation will be equal to 3.697 MPa. Now, when I calculate this, the problem he has asked, calculate the number of cubes. The problem is he has asked is calculate the number of cubes with strength or with compressive strength less than, with compressive strength less than mu minus 3 sigma. What is mu here? Mu is nothing but 26.575 minus standard deviation is how much, sir? 3.697. So if we calculate this, what is mu minus 3 sigma? It is nothing but 15.485 Newton per mm square. So we have is 15.485 Newton per mm square. So how many cubes are there with strength less than 15.485, sir? Sir, is there any strength here with strength less than 15.48? Everything is greater than 20 mm. So the number of specimens which are more than 15.485 is 0. The answer here is number of cube specimens which are more than 15, which are less than 15.485 is There is no cube here. Now, my dear students, we will move on to the next important question. A simply supported prismatic concrete beam with an effective pre-stressing force of 600 kilonewton. The eccentricity of pre-stressing tendon varies 0 at supports. It varies 0 at supports, sir. It varies 0 at supports and varies linearly at midspan. In order to balance a load of 12 kilonewton applied load, the midspan and the value of E is. This is the question they have asked, sir. So, my dear students, whenever this kind of question is asked, my dear students, first and the foremost thing what I would like to tell you is, first of all, here whenever these kind of questions are asked, this is a pre-stressor question, pre-stressor concrete beam. Here it is coming from load balancing concept. Whatever the load which is acting on the beam will be balanced by the load which is will be balanced by the moment which is due to the pre-stressing force. So this is the one which I want to explain you. So here what I would like to tell you. So here we will draw the first the question. We will draw the diagram here. So the first and the foremost thing is we have a simply supported beam. We have a simply supported beam. And in this simply supported beam, my dear students, there was a load which is acting at center. And that load is how much, my dear students? It is 12 kilonewton. And the total span is how much, my dear students? The total span is 8 meter. And see, my dear students, it is as it is acting at midspan. This distance will be 4 meter and this distance will be also 4 meter. Now, my dear students, if I consider a neutral axis here, if I consider the neutral axis, the tendon is triangular tendon because he told in the problem clearly that it varies 0 at supports to maximum at midspan to the 0 at another supports. He told clearly that it is varying linearly. So it is one of the triangular tendon. We have force here and here. So my dear students, whatever the load, so here there is an important concept. The load here is 12 kilonewton. So, and this is the portion of eccentricity. This is the portion of eccentricity. Now, if I consider this as theta, my dear students, tan theta can be written as, from the diagram, tan theta can be written as E upon 4 meter. Tan theta can be written as upon E upon 4 meter. And here, my dear students, here what is the value of E given? E value is given as how much, my dear students? Please see in the problem. E value, we have to calculate the value of E. They are asking what is the value of E only they have asked. So E tan theta is taken as E upon 4 meter. Now another thing. Now when I see here, my dear students, here we are having a pre-stressing force. Due to this, there will be one force here. And due to this force, there will be another force here. There will be another force which will act here also. What I would like to tell you. Sir, here if there is a resultant, here, there will be one vertical force. If I take this as, my dear students, if I take this as a pre-stressing force P, okay, if I take this as a pre-stressing force P, and now what will be this force, sir? It will be equal to P sin theta. It will be equal to P sin theta because the resultant is theta. If you consider here P, here the horizontal force will be P cos theta and the vertical force will be equal to P sin theta, which is I am telling you due to this pre-stressing force. Here also we have another pre-stressing force that will be also equal to P sin theta. So we have upward force is equal to P sin theta plus P sin theta. P sin theta plus P sin theta is equal to 12 kilonewton. So here, my dear students, I can write 2P sin theta. 2P sin theta is equal to 12 kilonewton. But remember, my dear students, they have given pre-stressing force is 600. So 600, 2 into 600 into sin theta is equal to 12 kilonewton. And pre-stressing force is also given as kilonewton. When I solve this, sin theta will be given as 0.01. Remember, my dear students, there is a math behind here. The math is for small values of theta. when I calculate for small values of theta, if I consider small values of theta, my dear students, tan theta will be equal to sin theta. Can anyone tell me how do you justify for small values of tan theta will be equal to sin theta? Because tan theta can be written as what, my dear students? Sin theta by cos theta. And remember, for small values of cos theta, because cos theta will be taken as 1, because for small cos 0 is how much, my dear students? It is equal to 1. So for small values of theta, cos theta will be taken as 1. So here tan theta is equal to sin theta. This is the one of the important thing I would like to tell you. So what is the value of sin theta here? It is 0.01. So 0.01 is equal to E upon 4 meter. So eccentricity can be written as 0.04 meter or 40 mm. So this is a very important question which is asked in one of the previous gate question. I hope you are clear in this. And remember, my dear students, if you have any doubts, you can ask me in the chat box. And please like this session and share this session to your friends. Now, I would like to give you some important insight of the RCC, my dear students. Whenever you are talking about RCC in GATE, in RCC we are getting 4 marks. You will be getting almost 4 marks. And in RCC, we mainly study about the limit state method and all the structural elements like slabs, beams, columns, and also footing. And we have to check individually also. We have to check for shear, check for bond, check for torsion. So these are the separate topics which we have to also study. Check for shear, check for torsion, and check for bond. These are the other topics, and also deflection will be studying you. And my dear students, working stress method is utilized only in water tanks, and so working stress method you can understand the basic. And also we are in T-beams, we talk about in beams, we talk about T-beam, singly reinforced section, and also doubly reinforced section. Apart from this, in pre-stressor concrete, my dear students, we have to concentrate on analysis and what is the basics of pre-stressor concrete. And apart from analysis, we also have to study about the losses. But for my concern, my dear students, I am giving a wild guess in 2023, as it is a paper from IIT Kanpur. You can get a question from LSM method. It is a wild guess, or you can expect a question from losses of pre-stress, or you can expect a question from the you can say moment formula or tension formula or compression formula or from shear concept. So these are the concepts where we can expect the questions in 2023. Now, my dear students, I would like to give you some insight of pre-stressor concrete. Already we have reinforced cement concrete. What exactly is reinforced cement concrete is? It is nothing but when we have different materials like cement and concrete, why do we go with RCCs? Because the RCC, these are the versatile material. They provide a huge compressive strength. That is the one of the thing. And the coefficient of thermal expansion for both the materials is almost same. That is the reason we are going with RCC. And coming to the pre-SC, that is pre-stressor concrete. In pre-stressor concrete, the section is efficiently used. As the cross section is efficiently used in pre-stressor concrete, the self weight is also reduced. If you see metro railway station or big spans, everywhere we go with pre-stressor concrete. And one more thing, it offers high resistance to fatigue loading. Fatigue loading is nothing but repetitive loading. And also it offers high resistance to impact loading. And also it offers high resistance to vibrational loading. So there are various advantages of pre-stressor concrete. In pre-stressor concrete, we have two methods, my dear students. One is nothing but the pre-tensioned, and other one we have is the post-tensioned, my dear student. We have pre-tensioned and we have post-tensioned. And remember, in pre-tension means the wires are tensioned before casting of concrete. And here like when we see railway sleepers, all the railway sleepers are designed using pre-tensioning. And remember, in pre-tensioning, bond is the main factor for transfer of stresses. Whereas in post-tensioning, end bearing is the main factor for post-tensioned members. So these are the basics of pre-tensioning and post-tensioning. Whenever you are talking about analysis of pre-stressor concrete, my dear students, I would like to tell you in analysis, sir, most of the people in RCC also, why do strain is assumed linear? What, sir, why do we assume some assumptions? Can anyone explain me? This is as simple as that. We assume some assumptions to make the complex problem into a simpler problem. So that is the reason we assume the assumptions. Sir, actually, I want to give you one important assumption, that is Bernoulli's assumption. What does that Bernoulli's assumption says is sections which remain in plane before bending remain in the same plane after bending. So this is the first and the basic assumption. This is the first and the basic